Hello everybody, I don't know if it's good morning or good night, so I'll just say hello. My name is Brandon Barnes. As you can see up there, I've already written it. I would like to go ahead and just dive straight into this presentation today. I'll be talking about motor programs. There's going to be a few things that I will speak about. Now I only have 5 to 10 minutes to talk about this. It's going to be a very quick overview of a few systems or a few topics in motor programs, but the first thing we're going to do is define it. If you would like, you can go ahead and pull up my presentation alongside of this and you can just listen to me, or you can have it side by side. First thing is define. We're also going to talk about the conceptual model. We're going to talk about problems with motor programs, which will be storage and novelty, and then we're going to talk about open and closed loops. Now, that was the best drawing that I could give you. Again, if you want, you can feel free to pull up my presentation beside this or the handout. So just a quick definition, it is signals transmitted through efferent and afferent pathways allow the central nervous system to anticipate, plan, or guide. Basically, the signals through our CNS are what help us plan, guide certain movements in our motor programs that help us achieve whatever task or whatever movement we are trying to accomplish at that time. The conceptual model. So I'm going to read these and then I'm going to define them a little bit further. The first one, it says to define and issue the commands to musculature that determine when, how forcefully, and for how long muscles are to contract and which ones are to contract. So let's just go into, so I am a coach, that is my career. And when I am watching kids, I'm a junior high coach, so that's why I'm gonna say kids. So when I am watching kids bench press, whenever you're bench pressing, your body needs to know which muscles to push. Your nervous system needs to know, your motor programs need to know, what am I pushing? What muscle am I using? So kids, they have this innate ability to want to use their core in a bench press. And by that, I'm just gonna draw it real quick. I didn't think I was gonna be doing this. But let's just say this is a person on a bench press, okay? You got the arms, you got the bench. So as you see, his feet or her feet are flat on the ground. Now that is taking away the core. Your core is tight. So if I put my feet on the ground, I'm not going to use my core to push the bar up. I should be using a few things. My front delts, my pec major, pec minor, and then my triceps. Basically, those are the basic core muscle groups that you're using in that. So your motor program is telling you to do this. Now, what kids tend to do is they feel uncomfortable, they feel like the weight is heavy, so they have to throw their whole body into it, and their feet immediately go from there to there. They shoot up, bang, shoot my feet up, and it throws everything off. And that's what happens whenever you don't have that motor program built in. You don't know which muscles to contract. So I teach them, let's drop this to a lower weight and let's get used to going slow on the way down. Spending your time building up that length, how long they are to contract. So I'm going down and then I'm pushing it. The next one is to organize the many degrees of freedom of the muscles and joints into a single unit. So again, what am I doing in bench press? I'm going from here to here, here to here. This is my degrees of freedom. I know that. I've done this for 10, 15 years now. As kids, they don't know this. Again, going back to my career, not everybody is a junior high coach, but if you notice, what they tend to do is they want to get that weight off of them. And the bar will either go, their degrees of freedom will not stay here where strict where they're supposed to be. They will go from here to their face, or they will go from here to their stomach, using no power. The degrees of freedom is completely gone. Their motor program is completely thrown off. They don't have the knowledge and the storage of what they're supposed to be doing. And then the next two are to specify and initiate preliminary postural adjustments necessary to support the upcoming action. That's one. We'll talk about squats. And then to modulate the many reflex pathways to ensure that the movement goal is achieved. So the first one, like I said, we're going to talk about squats. As kids, when you squat, you go down like this and then you come up. Now, if the weight is too heavy, as an adult, you have learned, well, it only has to fall an inch that way off my back. As long as I let go of my hands and I walk forward, the weight should go backwards. That's my postural adjustment. Instead of bending over, which is what a lot of the kids do, that postural adjustment, I can't support that weight going this way. I'm going to fall. The weight's going to go on top of me. As an adult or as somebody who has been lifting for X amount of years, I know, let me adjust my back, lean back, drop my hands, bar falls off, I'm good, nobody gets hurt. So that's the basics of defining the conceptual model. So we have done the conceptual model. Now we're going to go into storage problems. Again, if you're looking at my slideshow, problems, we all got them. It's okay. So novelty. That is a failure to account for how novel movements are produced in the first place. So needing different or new programs for every shot. So I read this paper, this research paper, that of course has been reviewed. And but my point is there was a quote in it that was talking about how no shot on a tennis court is necessarily new and no shot is old. Now, when I first read that, I was confused, and then going throughout the paper more and more, basically summarizing it, you have a person who has practiced tennis that's practiced so much that there is no new shot. They understand, let's just say that person, the person in the article had been practicing for 8 years. They've been playing tennis for 8 years. Thousands and thousands of hours of just swinging. So there's no new shot. However, there was also no old shot. So every time that person swung their racket at a ball, there was no new shot that they had created in their mind because they've seen it all. However, the old shots weren't the same one that they needed. So it was a combination of both, new and old, which is what they were saying. I can't create something completely new, but I can't use the exact same way that I attacked that ball before because there are so many different ways that it can be attacked. Now that goes into the next one, which is the storage problem. In tennis, there is so many, not just tennis is just the example I'm using because that was the majority of the papers that I read, but those are so many different types of angles and positions and speeds and ball control and court options. So you can go from sideline to sideline. You can go from the far back corner to up close. You can slam the ball. You can soft serve the ball. There's so many different things you can do that your brain, your motor program has to memorize all of these things to be able to do. And then the last thing, so this is talking about the open and closed loop. So just quickly, open does not use feedback, an example is in golf swing. Now I'm going to talk about that more specifically using that same paper that I read earlier. And then a start as it is finished. So let's talk about a golf swing. If I'm in a golf swing, I go from here and I start as I finish. Nothing, my body is just turning up, turning down. That's it, one swing, up and down. So nothing changes, starts as it is finished. Open, closed. I am using feedback, as it says, involves feedback from the brain, playing a tennis shot as an example, and then it changes because of our reaction, or the person's reaction. So now if I'm playing a tennis ball, I can come from here and then I can realize while I'm swinging, so my swing, same as golf, swing starts, finish. Here I swing, I start my swing, my feet are planted, I swing, I turn into it. Now I want the ball to go over there, so I flip my wrist. I've reacted to the ball. Or as I'm swinging, I notice the ball went a little higher, so I react and I come up and go down. I'm reacting to it. Same thing, let's just go into baseball now. Baseball, I'm here, ground ball, I shift my feet, and then I see the ball goes over, so I reacted to the ball, I drop my glove into a completely different position. I have now reacted and done something completely different than where I started. That's a closed loop. Now, if we want to bring this into a professional setting, let's say I am coaching golf. And I notice every single time my person that I'm coaching, they take their club, they swing up, and this front hand is bent, bent like this, okay? Well, if I come down swinging like this, if I hit the ball with this hand open, more than likely that ball is going to get hit and it's going to go out that way. Well, if I want the ball to go straight, I have to straighten that hand. Now, let's say this person is completely comfortable with their hand like that, and that's the way they want to do it. Well, in an open loop system, that's fine. I just turn their body and I re-angle them. I stayed open loop. Or if they can get more torque from their body being flat like this and they can't figure out how to get that ball to go straight, we are going to turn it into a closed loop motor program. So you're going to start one way, and you light that all the way up, and then you're going to react to your body being out of place and then turn that wrist down. So now I go from open all the way through, and then I can change it to a closed loop system where it's reacting. My wrist starts here, and now I react because I realize my brain has told my hand what to do. I need to switch. I need to go from here to here with my hands. So that turns it from an open loop to a closed loop. That's it for my motor programs. I know I went a little over. There's the works cited page. Please look at the handout. Thank you for watching, and I hope I get some good questions down below.